right, welcome back. I had to restart because I forgot to start the recording. So here you go. Addition property, we talked about it. The properties are just things that you are allowed to do. You're going to see lots of A equals B in this first part because this is like our setup. And what are you allowed to do in mathematics? You've been learning since Algebra 1, since pre-algebra, that as long as you add something to both sides, you'll be okay. As much as this looks like random information, kids that are in class probably going a little crazy here, hearing this twice, but all we did was add C to both sides, okay? It's not as jumbled up as it looks. You plus C on both sides, you're good. So what's the subtraction property? What do you think? A minus C equals B minus C, right? It is literally just the idea that as long as you do it to both sides, that's okay. Multiplication property is the same thing. If A equals B, that's where we start out, then we'll have A times B. And we'll just use a little dot. Sorry, I put a B there. It used to be a C. Trying to think and speak and do everything at one time. My bad, my bad. Multiply by C. A times C, multiply by C. One last super basic one that we've been doing for years. A equals B. And if we're talking about division, then, you know, there's two different ways to write this. You could use that old school division symbol, or you could use fractions. I tend to always like writing things as fractions, so I'm going to set it up like this. A divided by C and B divided by C. You might see it written with those division symbols, but I don't really like those. I like these fractions. Again, not rocket science. We already know this. We already know how this works. We just get names for them. They are literally the simplest possible names. Addition property, subtraction property, multiplication, and division. Okay, now we're going to get into some properties that actually require a little bit of mathematical kind of doing, but at the same time, we've seen all of these before. The first one after those easy four is the distributive property, which you better be understanding. This is like from middle school and Algebra 1 Part A and Algebra 1 Part B. We've got a number in front of some parentheses. Then how do you write that? You're going to put one of them in front of both of the inside pieces. That's going to be A times B plus A times C. Again, I know that that is a bunch of letters in a row, but it is literally the distributive property that we've been doing for years. You put the A in front of the B with some multiplying, and you put some A in front of the C with some multiplying.
What does that say? A times B?
What do you mean, what does it say? A times, it's distributive property. I mean, don't you know what that is?
Yeah, no.
So you got A times B plus A times C.
I just couldn't
Right?
see it.
I got you. The good news on these is you shouldn't even really have to look at the board too much, because you should be able to just kind of know what those are. Substitution property. All right. So substitution property is about substituting things in. Okay. It says then A may be blank by B in an expression or equation. What's up? We're kind of in the middle of the notes, but let me get through these next couple ones. To be honest, how do they want us to write this on substitution? Substitution is when we plug one into the other one. If then A may be substituted by B. Here, we'll write the word substituted here. And I'm not really sure what even is supposed to go in this blank, but whatever. We'll see it down on the bottom with the examples, and maybe we'll come back to figure it out. The last three are reflexive, symmetric, and transitive. I'm not quite sure how they want us to set this one up, but whatever. Reflexive is as easy as it gets. For any real number, a value always equals itself. This is the one that is so desperately, stupidly easy that it ends up being the hardest one. For any real number a equals a. And as ridiculously basic level as that is, reflexive property is somehow one of the most missed questions, because reflexive is not a word that you've really ever heard in math before. Reflexive doesn't have really anything to do. The best thing I can think of it is, you can think of it like it's reflecting like a mirror, right? So like reflexive property is reflecting a mirror. A equals A. It's looking at itself in the mirror. I don't know. That's the best I can do for you there. Symmetric property is always confused with reflexive property. If A equals B, then B equals A. So the symmetric property is what allows us to flip-flop things on both sides of the equal sign. A lot of times people reflexive and symmetric, they get really confused about which one's which. Symmetric, these things are symmetrical. As far as reflexive, again, the best thing I can tell you is you're reflecting a mirror of A looking at A. Okay, down here with A and B, they're switching places, so it's a little different. And lastly, the transitive property. The transitive property is basically the same thing as syllogism, if you still remember what that is from last week. So if we know that A equals B and that B equals C, right? There's our two sentences where the conclusion is the same as the hypothesis. Then we should be able to skip all the B parts and go straight from A to C. So our answer here is going to be A equals C. All right. E-all passes down? It's up for me. It's up for the 4 people that have gone so far.
It looks like.
All right. Hit refresh or give me a couple minutes and we'll try again. So down here, our goal is to name the property, look at these statements, and decide which one's which. This is not crazy. Just think about, how did we get from the if to the then? What did we do? Did we add something to both sides? Did we literally show itself? Did we flip it around? So for number 1, I see that k equals 3 is the start and 3 equals k is the end. Anybody got any ideas? It looks to me like the symmetric property. Okay? Symmetric property is literally how we're allowed to switch things over the equal sign. And because the difference between the if and the then statement is that they're just switched over the equal sign, then we should be kind of straightforward. Okay? Now number 2 is one that we should be more comfortable with. How did we go from 2x equals 14 to x equals 7? We made some progress. Numbers actually changed. What did we do? Did we add things to both sides, subtract things on both sides? What were we up to? Omar, you guys just like one of the, you like properties? Properties real funny for you in the back. What we did here is we divide. We divided both sides. We divided both sides by 2. This is the division property. Number 3, I'll leave up to somebody else. Somebody shout out for me, please. What are we doing for number 3? This is reflexive. Because nothing happened, right? I mean, literally it just says 10y equals 10y. No changes, nothing happened. It is literally just A equals A. It's just looking in a mirror. Nothing happened. Okay? Okay. Let me get through 6 and then I'll do it for you. Number 4, when we're actually handling these properties, the questions like number 4, as long as we remember that reflexive is different from symmetric. Questions like number 4 are normally the ones that people kind of mess up. We see that negative 5x minus 1 equals negative 11 is going to turn into negative 5x equals negative 10. Something happened. We did something. We always do the same thing to both sides. Really, we need to decide between the addition property and the substitution property. Okay? I know that I didn't multiply anything. I know that I didn't divide anything. Did I add something to both sides, or did I subtract something from both sides? So even though this is a negative 1, right, and this negative 1 disappears, how did we move that negative 1? We moved it by doing plus 1 on both sides. And so it's kind of the opposites. When you see that that minus 1 is gone, remember it was moved using addition. So this is the addition property. And let's do 2 more. If 10a equals 2b and 2b equals c, then 10a equals c. This is our most complicated one going on here. What do you think? Transitive. That's exactly right. This is going to be a transitive property because we got our little syllogism. We got our little 3-parter, right? We got the first part is equal to the second part, and the second part is equal to the third part. And so what we say at the end is cut out all the 2b stuff and give me just the 10a equals c. All right, last one we're going to do on the video here. 6 negative 7 parentheses n minus 4 equals negative 7n plus 28. What do you think? Distributive. Of course. Please, distributive. Like, that's got to be almost the easiest one. Okay? Distributive, we've been doing it for years and years and years. All right, that's our different properties. Finish this out. We're going to talk about how they're incorporated in proofs in a little bit.